In the previous lesson, we looked at theoretical probability. That's what we think, that's what we expect will happen. If we have a look at this dartboard, if we exclude the middle bit, we could say that each number here would be equally likely, and the possibility of getting, the probability of getting a 20 would be 1 out of 20, because there's only one 20 there. We would write it like this. Here, 20 in brackets is equal to 1 over 20. However, if I start throwing darts at this dartboard, you might find that I can't hit a 20, and I hit a 6, and I hit a couple of 6s. So you could then say it's more likely, it's more probable that I hit a 6, because everything I keep throwing ends up being a 6. So here in front of me, I have some darts, and I'm going to throw some darts at the dartboard, and we're going to see what happens. Alright, I threw 10 darts, and you can see from here that certain numbers are more likely to be hit when I throw the darts than what we expected. We said that the probability of getting So I threw 10 different darts. I got 2 20s, I got 2 1s, I got let's have a look at what I just got. So I got 2 20s, I got 2 1s, we'll call that an 18, a 15, and a 7. So what I did was I did an experiment where I threw 10 darts at the dartboard, and now we can work out the probability of me hitting a number based on what happened. So I hit 2 20s out of 10 darts. So the probability of me getting a 20 would be 2 out of 10. The chances of me getting a 1 would also be 2 out of 10. Chances of me getting an 18 would be 1 out of 10. And the chances of me missing and getting no number whatsoever would be 3 out of 10. So we can use experimental probability to find a more accurate chance of something happening. And we can also use experimental probability to find if there's any issues with our experiment. So for instance, if a dice was rolled and you kept getting 6s, well, maybe the dice is weighted. So you would think getting a 6 would be 1 out of 6 as a probability, but it's actually almost certain to happen because the dice is weighted. So we need to trial experiments, trial things to get an accurate probability rather than just basing things on what we think will happen. Using that dartboard as a continued example, we can say that the expected probability equal to the number of successes divided by the number of trials. So bringing up the dartboard on the left side of the screen, the total number of trials was 10. We threw 10 darts. So the total number of trials, so the total trials was 10. And we talked about getting a 20. So how many 20s did we get? We got 2. Got 2 20s. So 2 is the number of successes, and 10 is the total number of trials. So to write the probability, we would just write 20 equal to 2 out of 10. And we can see we have a common factor of 2 both in 2 and 10. So this would simplify down to, so 2 divided by 2 just be 1, and then 10 divided by 2 would just be 5. So the odds of me getting a 20 based on that experiment was 1 out of 5. Now, I'd like you to give this a go. Don't always just use other people's experiments. Give it a go. Find a coin, find a counter, and you can set up a table like this. Heads, tails, then you just write a tally up the top. So if you flip a coin and you get a heads, put a mark there. You get another heads, put another mark there. Find out your total number of heads and your total number of tails, and then use the probability formula to find out what's the chances of you getting a head, what's the chances of you getting a tails. Give this example a go, have some fun with it. Good luck with finding the probability, and good luck with those questions. See you in the next one.
Spider-Man, Spider-Man, does whatever a spider can. Spins a web any size, catches thieves just like flies. Look out, here comes the Spider-Man.